This is the brief on tidal gravity and deformation. Okay, so we're looking at the core physics that explains how these massive bodies stretch and squeeze everything around them. We're going to dive into the actual math that generates this whole tidal effect. So let's get right into it. First, that stretching and compressing we associate with tides, it's not just one thing. It's actually two different forces working together. You've got one part, the shearing term, that's responsible for the stretching, literally pulling things apart. But then at the same time, there's a second part, the compression term, that provides this uniform inward squeeze all around. Second, the tidal force itself is all about differential acceleration. You know, it's not the total pull of gravity, but the difference in that pull between 2 points on an object. And to describe this precisely, we use a mathematical tool called the tidal tensor. It neatly captures all the information about how an object is being stressed. And finally, this tensor is super useful. We can actually compute it for real-world scenarios, like for something orbiting a perfectly spherical planet or star. Because we already know the basic gravity equation for a sphere, we can use it to figure out the exact tidal forces at play. So, tidal forces really just come down to this combination of distinct mathematical parts and those crucial differential effects.